Welcome to TechTalks, the podcast by the Copco Group that delves into various technologies and their transformative impact on the future. I'm Linda Ekwall, your host, and today we will uncover the hidden heroes behind many of our daily conveniences: pumps. Pumps are all around us, quietly performing essential tasks every day, from simple household chores to complex industrial processes. But despite their importance, these versatile devices are seldom mentioned. Now, to shed some light on this fascinating technology, I'm joined by 4 internal experts who will share their insights and expertise with us. With me here today, I have Karin Biller, Head of Product Management, Giulio Ferrarese, R&D Team Leader. We have Tanya Palmer, Vice President Engineering, and Ian Stone, Vice President Technology. Welcome, everyone.
Hi. Hey, Linda.
So let's start with the basics then, Giulio. What is a pump and how does it work?
So a pump is a device that uses energy to move fluids from one place to another. They are really important in many fields of applications, like, for example, in industry or chemical or distribution, water distribution, etc. They have much different sizes. They can range from the smallest, that are almost a few millimeters, that can be used for medical dosing, or the biggest, that can be as big as a 3-story building, and that can move up to 50 cubic meters per second. And that can be used, for example, to defend cities from floods. The energy is transferred to the fluid, for example, transferring kinetic energy, or creating areas with low and high pressure, or maybe just moving a fixed volume from one place to another. And the mechanism that the pump is using depends on the type of the pump, so there are many different.
And how about vacuum pumps then, Ian? Is that the same?
Yeah, vacuum pumps work on very similar principles to Giulio described, to remove gas from our customers' systems and create low-pressure, clean, controlled environments, which are really critical to their processes. One unique difference with vacuum is that when you get to really low pressures below about a millionth of atmosphere, then the gas stops behaving like a fluid, because the gas molecules are so far apart they don't interact anymore. So then we need different mechanisms. So often for really low pressure systems, you'll see 2 or more different vacuum mechanisms to evacuate our customer systems.
What types of pump do you have in your field of business? And we can start with you then, Karin.
Generally, you can categorize pumps in 2 different types, right? So you have, first of all, positive displacement pumps, which work by entrapping a fixed amount of fluid and then moving it to the discharge line. And if you have a liquid soap dispenser at home, you can screw the top off and look inside and just get a knack of the technology behind. And those are really good for high viscous fluids. So in industrial sector, we have gear pumps, we have low pumps, and we have progressive cavity pumps, for example. So those pumps are really good for high viscous fluid metering and transfer. And you also have plunger pumps and diaphragm pumps, which are good for high pressure applications, for example, in the chemical industry. And then we have the dynamic and the kinetic pumps, which actually work by adding momentum to the fluid, and by this they are creating pressure or velocity. And the most common type there are centrifugal pumps, and they do so by a rotating impeller. And yeah, you probably know them from your heating system at home, right? That is where you come across. But these are very good for low viscous fluids and for high volumes. But in the industrial sector, these type of pumps are used for way much more than heating.
And Tanya, is that also the same then in the vacuum technique?
So as Ian said before, we're talking about molecular flow in the semiconductor space. So we use both displacement and kinetic pumps, but actually we have a third category and we call them entrapment pumps. And they work by both condensing, so freezing onto a cold surface, and also absorption. So they are able to take us down to those very high pressure capability and in that molecular flow where you've got less molecules and they're less likely to collide. So the different mechanisms there. And in our space, in the semiconductor space, or actually in vacuum technique, we have across those three categories about 15 different pump applications. And for us in semiconductor, in order to get to those pressures, you have a stacking system of pumps. So you stack the pumping arrangement to be able to get to those pressures.
Could you give us some examples of the 15 different applications?
So I'm going to stay local for me, but obviously if you start in my space, we talk about cryogenic pumps. So we have cryogenic pumps that do the condensing and the absorption, so the entrapment mechanism. If I look at the kinetic sample, for me, it'll be turbomolecular. So again, at those molecular flows. But if I look across that, we also have our dry pumps, our screw pumps, our scroll pumps. So, the 15 goes on.
Yeah. I can hear there's a lot of different pumps in the world, and especially in our world here. Yeah. Pumps are often unsung heroes. Can you, Ian, explain why they are so important to our society?
Vacuum enables so many products we rely on. Without vacuum, you wouldn't have semiconductors, so you wouldn't have smartphones, you wouldn't have solar panels, you wouldn't have advanced medicines and long-lasting high-quality foods, just to name a few. In fact, we wouldn't have this TechTalks without vacuum.
So vacuum's really quite essential, isn't it? So, we use it in medical research, as Ian has explained. We use it in many, many applications. The semiconductor space is a great example of that. And also, as part of the vacuum space, we have a commitment to be environmentally sustainable. So for us, that's one of the things that we're really thinking about in the future is thinking about how we can be sustainable and how our technology can help to deliver sustainable solutions. And so really one of those is how we can do more for less. So that's an exciting challenge for us. More for less.
Great. And do we have some examples of those global challenges, Giulio?
You have to think that the Earth is a blue planet, so 70% of its surface is covered by water. But despite this abundance, the water is not always in the right place in the right time. Sometimes it's not usable or not accessible. And that's where our powerful device comes in. So the pump is helping on this. So whether it is for water distribution, drinking water distribution, or irrigation of the field, or in constructions, or for water disposal also, pumps are always working silently and tirelessly.
Yeah, I feel pumps are everywhere, right? So they are playing an important role in the public sector, in the private sector, and also in the industrial sector. And they are, for example, if you've been asking about challenges, they are also important to tackle our healthcare challenges. So if you take, for example, the production of antibodies, and antibodies are used in diagnostics and also in modern cancer treatment. And in order to purify these molecules, you need really precise metering pumps.
What is the most unknown fact about pump technology, and what do people not know?
So one of the most exciting facts for me as I came into the industry in the turbomolecular pump, so in the molecular flow range, the kinetic pump, is actually it magnetically levitates. So it flows. So we've got this high spinning rotor at maybe 670 miles an hour or 250 to 300 meters per second. It's floating. Magnetically floating. So I think that's really exciting, and I see it as magic, but actually it's great engineering behind it. And maybe another little fact is around the Hadron Collider. So the CERN Hadron Collider, where you've got 100 kilometres of piping, where you've got particle excitement, and pumping is a huge part of enabling that technology and the future of science and in exploration in the physics space.
Yeah, and if I can just add up on that, CERN is actually also using industrial pumps in order to cool their equipment because they're pumping liquid CO2 into a cooling circuit there. Yeah, but I think it's a great example how pumps are relevant for research, and they are also playing a big role in the decarbonization of the marine industry. Yeah, so as you might know, marine transport is 80% of good transportation in the world at the moment, and that adds up to about 10% of transport emissions. Yeah, and in order to reduce those, alternative fuels like methanol, like LPG and ammonia play a key role. Yeah, and although these fluids have low or no carbon content, like ammonia, they can still be harmful to the operator prior to combustion. Right. So in order to inject these fluids safely into the marine engines, you need really tight and leak-free pump technology. So that is where we come into play, of course.
Do we have any fun facts to share?
I have a numbers fun fact for vacuum. So on the very low pressure systems, then our vacuum pumps can reduce the pressure in our customer system to less than a trillionth of atmosphere. So that's 99.999999999% of all the gas molecules removed. So it's like creating a bit of space right here on Earth.
Mm-hmm. I also have a couple of fun facts about our technology. I'm Italian, so one of the most ancient machines invented was in Archimedes' screw pump. That actually had been invented around 200 BC while he was in Egypt. That pump, the purpose was for irrigation in the field. And nowadays it's still in use, and it is still almost the same. And it is moving efficiently fluids, also with solid contents. Another fact that it is a little bit less fun, but can give an understanding of how important pumps are, is what happened in Pennsylvania in 1979, where at the nuclear power plant of 3 Mile Island, a partial meltdown of the nuclear core happened, and the disaster was prevented by the emergency system, who turned on the cooling pumps that pumped water inside the reactor, avoiding the disaster and likely saving thousands of lives. And this fact actually led to major reforms into the safety of nuclear power plants and also operation worldwide.
Mm-hmm. Interesting that we have inventions that we use still that were invented so many years ago, and also how different applications you can use the pumps for. So as you say, it's for nuclear, it's for these accelerators, it's for food production and everything in between. So really cool. What are some of the current challenges faced by the pump industry?
Yeah, I guess in general, we can say that it's a rising awareness of sustainability topics and the demand for connectivity from our clients. And it's also to meet regulatory requirements all over the world, right? But I also like to think that it's both a challenge and it's an opportunity for us in order to differentiate in this wide market and create the best products for our customers. But take, for example, the food industry, where product integrity and product safety is very relevant for taste, for example, and in order to ensure the quality and the safety of our daily nutrition, right? So you have to design pumps to the highest hygienic standards to fulfill this need of our society.
In portable flow, we have different kind of challenges. For us, the versatility is key. Our pumps are not actually operating always in the same operation mode. We are inside different field of application. And on top, sometimes the conditions are changing while the pump is working. So our pumps are built to last, to fit the purpose. They need to work efficiently, also in different conditions. And the material offering need to tackle different media, also corrosives.
Where could you then see corrosives in when you're pumping? When would that happen?
Seawater is the most common one, I would say. And that's a typical application. And everybody knows that seawater is really harmful for steel, but you can't imagine how much it is unless you see the metal corroded.
I think in vacuum there are two, if you like, challenges and opportunities that we try to balance. And one is trying to solve our customers' complex application challenges. So you imagine in semiconductor, we also have corrosive gases and toxic gases. And then at the same time, we're very focused on making our products as energy efficient and sustainable as possible. So the energy reduction is a primary focus. That's our biggest opportunity to reduce the carbon footprint of our products. But second to that, we also want to look at the materials usage, like circularity and reducing waste, and undesirable materials like PFAS chemicals, these forever chemicals that accumulate over time. So there's a real challenge there to try to replace these PFAS materials, which are really advantageous from an engineering perspective, but present a hazard to biodiversity, and at the same time replace those with materials that don't compromise on quality or performance or functionality. So it's that balance between the customer application and the sustainability of our products.
And how do you attack that challenge then?
The PFAS challenge. So there are some alternative materials, but not many. So in some cases, we can just find an alternative material and replace the same design of components. But a lot of the time, we're using these PFAS materials because they enable us to do things that no other material can. And therefore, we have to bring innovation to the game to find totally different ways to solve those material challenges.
And one of our big challenges is sealing, right?
Sealing, lubricants, all the really important things in a vacuum. But yeah.
Have forever chemicals.
Have forever chemicals.
Yeah.
Okay, so maybe I can pick up on a couple of points. So compliance and corrosion, maybe. So in compliance, if we talked about that third category of pumps again, so the entrappment pumps, we're using F-gas materials in there, and they are highly constrained and increasingly coming under some strong compliance changes. So one of our big technology researches at the moment is to look at lower global warming potential gases. It brings with it, unfortunately, a different challenge of flammability. Now, we have this challenge in our homes, in our refrigeration capability. But for us, though, the management of our F-gas compliance, the lower GW, so the lower global warming potential gases is a great big challenge for us, and it's one that we're working very hard on, we're very excited about, and actually again it could be something that really differentiates our pumps. But importantly, what it does is it contributes for us to the environmental commitment that we need to make our technology useful for the future.
What type of gases is it you're talking about?
Super light gases, so helium. Helium is a big contributor in our pumps, and I didn't mention it before, but in the entrapment space we will also have a unit called polycold, and it's in the polycold where we use these these high GWP refrigerants, and that's really where the focus of our technology is at the moment.
So on the topic of sustainability, can you highlight some of the successful sustainability initiatives going on?
I think Atlas Copco Group has recently introduced, or in the last few years, science-based targets. I think science-based targets is a tough challenge for us. It sets a high bar for change. But what's exciting in our space is it creates the opportunity for us to innovate, to use technology to solve some of those problems in the sustainability, and also help us to differentiate our pumping capability. So science-based targets is a tough initiative, but actually it drives innovation and technology, which is good for us.
And as you say or pointed out, we committed. The full group is committed to the science-based targets. So
Absolutely.
It includes all the brands within the Atlas Copco Group.
Absolutely.
And it's not just the products that are becoming more sustainable. They're also enabling lots of sustainable tech like electric vehicles, solar panels, green steel, even carbon capture systems use vacuum in their production and processes.
It sounds like pumps play an important role, and it will continue to play an important role in this low carbon society. Is that a correct assumption?
Absolutely. Yeah. I mean, we cannot forget how important pumps are also for, reaching our climate goals. So take, for example, the industrial production of biogas. So biogas is when organic matter is, converted by microorganisms into gas. Yeah, so this organic matter can be animal waste, it can be food waste, it can be agricultural residue. And yeah, you might not be surprised by now, but pumps play a crucial role in order to transport and recirculate this kind of feedstock into the fermenter. So you can basically say that pumps play a key role in converting waste into renewable energy.
And the reduction of carbon footprint goes also with the optimization and the energy efficiency of our units. Our recent product launch of electric units that implement the variable frequency driver are allowing the customer to steer the speed of the electric motor according to the need. And this leads up to 30 to 40% energy saving, especially if the pump is powered by a generator. And furthermore, more efficient electric motors can lead up to a 10% energy efficiency. And also the implementation of new controllers and systems inside the pumps as a standard are allowing us some intelligent control system, especially for priming.
And I guess this also connects to the science-based targets that we need to help our customers reduce their amount of
yeah, it's a matter of changing the culture sometimes. Yeah.
What future directions do you see then for pump technology? If we start with vacuum.
Okay, so I think one of our exciting opportunities is quantum. So we talked a little bit before. So quantum gives us a huge opportunity in the pumping capabilities and driving our technology even further, but also in the MRI. So if we think about in the medical application and the MRI application. So for our cryogenic, so our entrapment pumps, we were talking before, the cryogenic spaces, there's a lot of opportunity there that we're working on a number of projects across the vacuum area. Also for me, in the turbomolecular space, so our kinetic pumps, our molecular flow, we're talking about ever-increasing speed requirements, the flow requirements of the pumps. And that's to enable the processes within that space to be able to etch. So in an etch application in the semiconductor, to etch even more aggressive and deeper channels to be able to create the sort of memory space that we need across the industry. So those cryogenic and turbo applications are maybe two.
And Tanya, you mentioned a few applications there. I think also for the products themselves, then, as you mentioned, Karin, connectivity and having really good analytics capabilities to really see our products through our customers' eyes, how they're being used and how we can optimize them. Then we can improve their productivity.
Uptime.
We can improve their uptime. We can reduce their energy. So it's a real win-win having those connected solutions with good analytics as well.
Is then the same for you, Karin?
Yeah, I guess apart from connectivity and sustainability, we've already discussed a bit. The magic really lies in understanding the customer process, And some of the trends we already heard is also calling for new materials. So for corrosion resistance, which is an ever-ongoing topic, there have been new metal alloys in the last years. And you also have, for example, the trend in the pharmaceutical industry to go more into single-use applications. So there are new materials to discover and to implement for us as well in order, to be ahead of the markets or evolve together with the market space around us.
And furthermore, the introduction of new AI technologies, especially during design phase, the manufacturing, the operation, and also the optimization of the whole system will have a key role in the energy efficiency of the single unit, but not only, also from a system perspective of the units.
So you mentioned AI. How do you use it? What do you use it for?
AI, especially now, we are trying to implement it during the design phase. This is enhancing our efficiency and also the time that it is needed to make simulation and to make trial and error on different design purpose. And this is allowing us to move at a really fast rate.
So what is the most fun part about innovating in this field? What keeps you on your toes, Giulio?
What excites me about engineering pump pump engineering is that basically it's really a dynamic environment where innovation is always present. Our technology is, as mentioned, really important for countless industries. And we are working in many different fields, for example, fluid dynamic, material science, and everything. So it's a really wide application of science, and I love it. And furthermore, the new technology that we mentioned before are allowing us to grow at a really abnormal rate. AI and all of these tools are not only affecting the design and the simulation, as mentioned. I'm an engineer, so that's where I'm working on. But basically, they are transforming what's possible.
Yeah. It's really interesting to hear your excitement about future innovations. Is there anything else you would like to add to this conversation before we end?
And I would say to everyone that's listened to this, if you've got ideas, reach out to us, because we far from know everything. You know, we're always interested to learn more from other people, but also importantly, if there's a great idea, we want to know about it. So innovation can come from anywhere, small or large. It's exciting for us.
Yeah. Yeah, and I for sure learned a lot today. So thank you all of you.
To you.
Yeah.
Thank you, Linda.
Thank you. Thank you, Linda.
This concludes today's episode on pump technology. For more information about us, go to atlascopcogroup.com. In the upcoming episode, we will continue the conversation on different technologies that are essential for society to function seamlessly. Thank you to Karin, Giulio, Tanya and Ian, and to everyone listening. Take care and see you soon.